Good morning, everyone. The bell work for today. Go ahead and solve these three problems and state the number of solutions. Okay, so on the agenda for today, that was the bell work. We're going to do notes. We're going to start them. Notes section 4.4, completing the square. You should find a copy of this in your notes tab. And then homework is just working on any missing assignments that you have. By the end of class today, you should be able to rewrite quadratic equations by completing the square. That is your goal. So think about how many squares would it take to complete this square. We worked with the algebra tiles before in a previous chapter. Now looking at this image, if we wanted to finish this square, how many single digit squares that are just worth 1 unit, how many would we need in order to complete this larger square? And you should have said 4, right? Because if we look at this image, we have a 2 by 2, so it would take 4 individual units to complete this image. So that's the same thing as saying if I had the equation x squared, remember this square here represents the variable x squared, and then each one of these bars represents x. So we have x squared, and then we have 4 x's, 1, 2, 3, 4. And if we added those individual little unit squares, we would get 4 of them in this corner, which is that plus 4, okay? So this is called completing the square, right? We're figuring out how many single unit squares would we need to complete the image. And in this case, we would need 4. How many would it take to complete this image? And again, if we look at our picture, how many x squareds do we have? And how many x's do we have? So you should have said we have 1x squared, because that's this blue square, right? That's our x squared. And then we have 1, 2, 3, 4, 5, 6 x's, those bars. So how many single unit, 1 unit squares would we need in order to complete this picture and complete the square? 9, right? Because we have a 3 by 3. So if we filled up each space, that would give us 9 square units to fill in. So doing this, completing the square, we're not always going to have a picture drawn for us like in the last 2 examples. Majority of the time, you're just going to be given an equation that you need to complete the square for to figure out what's my missing units in that corner. So whenever we have an expression x squared plus bx, we can make it into what we call a perfect square by adding a specific value to the expression. This process, we call it completing the square. Notice in the last 2 examples, our x squared always had that a value equal to 1. It was always 1x squared, right? In order to complete the square, your a value must always be 1. If for some reason it isn't 1, let's say you have 2x squared or 3x squared or 4x squared, whatever it is, you need to make sure that you factor out that a value so that your a value is 1 before you begin the process of completing the square. Okay, and so the first step is when we're completing the square, you're going to take half of your b value, which is the coefficient of x. Okay, so you're going to take that number and you're going to cut it in half. And then whatever number that you get, so say that your b value is 8. And if you cut 8 in half, that becomes 4. So you're going to take that 4 and you're going to square it. So 4 squared is going to be 16. Okay, and you're either going to do one of 2 things. So you can either, you're going to add that value to your equation. So again, that's 16. So say it was x squared plus 8x, and now it's plus 16. Okay, so now you have that plus 16, and now you're going to do one of 2 things. Either that result of 16, you're going to add it to the opposite side of your equation, or you're going to keep it on the same side of the equation, but you need to make sure that you do the opposite of that. So since it's plus 16, you want to show that you're also going to minus 16. And the reason for this is because, remember, you don't really want to, you can't just manipulate your equation and change it into something completely different just because you want to. You have to make sure that you're still keeping the equation balanced. So if you're adding 16 to the left, then you need to add 16 to the right. Or another thing that you could do is if you add 16 to the left, then just also subtract 16 from the left. Because if you add 16 and subtract 16, you end up with 0, right? So in reality, you really didn't make any changes to the equation because you kept the change at 0. Okay, so those are always your two options. You could either do the same exact thing that you do on your left, do it to your right, or whatever you do to your left, just also make sure that you do that same, whatever that number is, you just take the opposite of that number and you also add it to that same side. Okay, and it'll make more sense when we do the example right now. So like, for example, we have the expression here, x squared minus 8x. Okay, so again, that first step is that you take half, right, of your b value. And in this case, my b value is -8. So if we take half of -8, we get -4. And then we're going to take that -4 value and we're going to square it. So -4, if we square it, is 16. So that means that to complete the square, I can say x squared minus 8x plus 16. Because notice when you do this, you get a really nice factorization of this statement. Because if we have plus 16, then when we factor it, it's just x minus 4 times x minus 4, which we could even rewrite that further if we wanted to, since these are both x minus 4. We could just show that as x minus 4 squared. So that's the point of completing the squares, that you're always going to get these super nice factorizations from your trinomials, where it's always going to be something plus or minus something else, and then you could just square it. Okay, that's the point of completing the square. Go ahead and complete the square for this expression, and then afterwards factor your trinomial. So again, if we take -9 and we cut it in half, we get -9/2. And then I'm not going to make this a decimal. I went ahead and I left it the fraction. And so if we take -9/2 and we square it, -9 squared is 81. 2 squared is 4. So it becomes 81/4. So then we have x squared minus 8x plus 81/4. And again, factoring it, it's always going to come out super nice. We have x minus 9/2 times the quantity of x minus 9/2, which is the same thing as saying x minus 9/2 squared. Okay. And you're always going to notice too, is basically what you should get for these simple ones is from step 1, notice that value that ends up just being the value that you're adding or subtracting from your variable when you get to the very last step. So that's what should be happening, is whatever value that you get here, you should see it being used in your final answer for your expression. Okay. So this is called completing the square using vertex form. So we have the function f of x is equal to x squared minus 16x plus 15. Okay, we want to put this in vertex form so we can easily identify the vertex. So notice right now it's in standard form. Okay, so we want to put it into vertex form. So we're going to do this by completing the square. Okay, so notice what I did was I grouped these first two terms together, the x squared and the minus 16, and then I left a space because I want to be able to complete the square. So I need to basically think of this as your magic number. You need to find a number that's going to create a nice perfect square. And then that plus 15, we're just going to keep it here on the outside because the 15 wasn't going to give us a nice perfect square. So we just went ahead and we're keeping it outside of the x squared minus 16x. Okay. So this is what we're going to be using to create our perfect square, to figure out what is that perfect magical number. Okay. Now the negative 16 is my b value, so I'm going to go ahead and take my negative 16 and I'm going to divide it by 2, and that's going to give me negative 8. Okay. So that negative 8, I'm going to square it, and that's going to give me 64. So that means in order to complete my square, I'm going to need to put that plus 64 right here in this space. Okay. So I have plus 64. But now remember what I said, we have to keep this equation balanced. We can't just add or subtract things because we want to. That switches the original equation, right? So whatever we do, we have to keep it balanced out so that really we're not changing what we originally started with. So since I added 64 to the equation, I'm just going ahead and I'm subtracting 64. Because if I do this, the 64 and the minus 64 will cancel each other out, right? So it's really like I didn't change this equation in the sense that it's still the original equation of what we had. If we get rid of our 64s, we're left with what we have originally. We're just, again, rewriting it so that we get a perfect square. So by subtracting the 64 on the outside, since we added the 64, really since those cancel each other out, we didn't change our original equation in any way. Okay, and then notice from here, we can continue on and we can factor what's inside of our parentheses. And when we do that, we have x minus 8 times the quantity of x minus 8. So we just factored out this piece. And then on the outside, we still have that plus 15 and that minus 64. And then notice we could rewrite this portion because it's x minus 8 happening twice. That's the same thing as saying x minus 8 squared. And then on the outside, we can combine these two terms, and that gives us negative 49. So that tells us now that our equation is written in vertex form, we can easily see our vertex is 8, comma, negative 49. Remember with vertex form how your inside value, always think opposite. So even though this is x minus 8, our vertex is positive 8, comma, negative 49. Okay, and then this is a minimum point, and we know it's a minimum point because our parabola is positive. It's an invisible positive 1 in the front. So that means it opens up, so this is a minimum point. Okay. Okay, go ahead. We're going to do the same thing with this function. We're going to write it in vertex form, and we're going to say what the vertex is and then whether this parabola has a minimum or a maximum point. So go ahead and try it right now. So the first thing you should have done is taken that value of 20, divided it by 2, and that gave you 10. 10 squared is 100. Again, because we're adding 100 here on the inside to keep things balanced, we also are going to subtract 100. Okay. When I do this, I can go ahead and now on the inside, these three terms I can easily factor, and that's going to give me x plus 10 and then x plus 10. And then notice these outside numbers, I just went ahead and already combined them together. Negative 21 and negative 100 gives me negative 121. From here, I can rewrite this portion of my equation as x plus 10 squared and then minus 121. So then I can go ahead and state my vertex is negative 10, comma, negative 121. Again, keeping in mind that this inside term, always think opposite. And then this is again a minimum value because the a value is positive. So that means that that point is the minimum because the parabola would be opening up. And we're just going to end it there for today. We'll talk about these problems on Monday as well as finish these notes. I hope you all enjoy your weekend.